Mhm.
Okay, so yeah, I'll start recording. So okay, start again. Hi everyone. So yeah, thanks for coming. We were supposed to have two talks today. So the main talk by Bruno, and I was supposed to do a short talk at the end about our COVID-19 platform. I won't be able to do it today. I'll do it next month, but I'll send a link in the chat for those who are interested to go have a look. Okay. So the main talk for today will be from Bruno, who's a PhD in the Economics University of Grenoble. And I guess I understand a teacher in Brazil also, professor in Brazil also. Okay, cool. So, well, I let you introduce yourself and start the talk. And thanks so much for doing this talk, Bruno.
Okay, very good. Okay, thank you very much, Mathieu. I'm sharing my screen with you guys now. So, first of all, I would like to thank you, Mathieu, very much for this opportunity. It's a pleasure to be here with you today. I hope everyone is fine in the current situation. And I'm I'm a PhD student at the Université Grenoble at the laboratory CREG, Centre de Recherche en Économie de Grenoble. And I'm also a lecturer or assistant professor. Sometimes it's hard to translate the position in Brazil at the economics department. So I'm here to present to you how to collect and use open access World Bank data to know your country. This is my first R presentation, so I'm really happy to contribute to the community, to the R community. I've gained so much with the community. It's an awesome place to learn and to advance your knowledge in your specific topic using the tools provided by the R community. First of all, let me just show you here at the top left, at least my top left, I think it's yours too. There is a button, fork me on GitHub. So when you click it, you go to GitHub or GitHub, I'm not sure. And you can see all the files that I'm using to do this presentation. So there is the Handson file, the words maps file, and also the Hans Rosling's Gapminder file. And if you're interested in the presentation too, the file is here. So you can find all the code to do the same presentation that I'm doing here. And feel free to use it and to ask questions and to send me an email or whatever. Okay, so oops, just let me change this here. Okay, we're back on. First of all, a general view on the package. It's called WDI, from World Development Indicators. This package, it allows us to search and collect data from the World Bank. As you may know, there are several data sets available with thousands and thousands of variables. So what are the advantages of using this package? Mainly with R and this package, you can easily do the reproducible research. So by putting your code on how you collected your data, you can provide this to someone else and they can know exactly what you did, exactly what variable you collected. Some journals, some peer-reviewed journals, today they ask for a data set, but some of them also ask for a code or a command that you use it. So you can provide this file as a supplementary material for your research, for your mainly your article submission. You can also collect annual, quarterly, and monthly data in long format. This is very important to do econometric estimations, for example, but also to dealing with plotting and other features in R. So you can easily collect and plot, analyze, and estimate econometric models in the same free software in R. Some important links. This is the link for the package website developed by Vincent Arrow Bundock. Also the website for data bank, where you can check the variables details. And there is an alternative package called WB Stats, which basically does the same thing as WDI, as the package that we are showing today. But one of the advantage is that you can search for variables in other languages. The same language that are available at the World Bank, for example, Spanish or French. Okay, some hands-on. This hands-on was developed based on the package website. So I'm basically copying and pasting the same code provided by the package, by the vignette of the package. To install the package, you just do install packages WDI. To search for data, you can use keywords. For example, if you want to search for GDP, the gross domestic production, you just type the command WDI search GDP, and you can create an R object of this search. So you can click on it and you can type the keyword that you are looking for, and you can easily search for the indicator. This is one way to do it, mainly for beginners. As I must admit, I'm an R beginner. I'm not advanced on this. On how to collect your data, I'm going to give you just two examples here. First of all, GDP per capita for France and Brazil. You can create an object. So first of all, you need the code that you grab it from the WDI search. And then with this code, you can create an object called, for example, indicator, where you name it. So I'm naming this one GDP per capita. And here you put your indicator. With this, we create an object, that1, which basically is the result of this, of the collection of this indicator, the data collection for this indicator. And here we are collecting for France and Brazil. If you have R opened right now, you can just copy the code here and try to do the same thing at your own computer. If you install the WDI package. By doing a head of this object, we just have a glimpse of the data. Now we are collecting two indicators. So GDP per capita in US dollars and local currency units. So we name this object indicators, which is just GDP per capita US dollar as the code provided by the World Bank. And next to it, we put the GDP per capita in local currency unit with the code that's also supplied by the World Bank. And now we create dat2 object, which is the result of this command. So we are using data until with the end in 2019. If you don't do this, it will collect data for 2020 with a zero. So for some variables, the World Bank provides projections. So it's nice to put an end to 2019 if you want the last available data now, for now. Plotting. So this is just a simple plot of the data that we just collected of the object dat1. We are using the library ggplot2. So by doing this command, we are creating a figure, a graphic with lines, with geometric lines. And we can easily see that Brazil has a much lower GDP per capita than France. With the second object that we collected, I'm going to provide you an example with the library, with the package ggtems. So with this package, we can add this command here, scale, color, and them economist. So we have the same colors and the same scale that you usually see in the magazine The Economist. We could change also the family, the font family, to match the same as provided by the magazine The Economist. So it's very nice. We can do some very interesting figures. Now we are using two lines, two groups of lines. One for the GDP per capita in dollars, and the other for the local currency unit. And by plotting both, we see that the dashed line, which is the GDP per capita in local currency unit, is lower for France than in dollars and higher in Brazilian reais than in US dollars. So as you may notice, it's very easy to collect the data provided by the World Bank. So instead of going to their website and clicking on a bunch of things, you can by using a simple code, you can collect the data from the World Bank. More details on the indicators. Here we are just creating an object called data info, which is provided by this command from the WDI package, which supplies us all the information on the series, on the variables. And by using it, we are focusing on the series and on the indicator GDP per capita. You see that we are also using the package dplyr because we are piping. This is a pipe just to simplify the next command that we want to do. That is to filter for the wanted indicator that we are interested in. And we can check the name, the description, the source database, the source organization. And here we are just extracting the description of this indicator of GDP per capita. So we provided you the information available at the World Bank website. You can do the same thing to search for the codes for the country codes. So if you create this object called data countries, you're just using data info and country. So with this, you can create the data countries object where you can check all the codes to use to collect the data for specific regions or countries that you would like to. As you may notice, the package also provides longitudes and latitudes for each country, and we can use this to create world maps, cool graphs, world maps with a specific variable that we are interested. That's what we are going to do next. So some cool graphs. This section is based on the WB Stats website, the other package that I mentioned. This package, I've just changed it's the same code, but I've adapted it to the WDI package. That's what we did here. But with the code provided at this website of this package, you can do the same figures, but using another package. So all this code here is provided by the website. So just to give you an idea here, it's loading the package R natural earth. So we need the world map. So with this package, we can easily plot the data that we collected from the World Bank in a world map. And we also need the Tideverse package to do some filtering and some piping and so on. So this is what we done before for GDP per capita, but now we are interested in the self-employed, which is the percentage of total employment of the persons that are self-employed as a percent of the total employment. We got the code provided by the World Bank, and we created this new object. One thing that changed here is that we added all countries. So we want every available country. And we are also using data for 2019. To extract the name of the variable, we can do it automatically. So this object is just to extract the name of the variable, because we are going to use it as the title of the figure that we are going to create. And also the source, we are extracting the source from the World Bank website. And that's the object that we are putting here at the end as the source of the data that we are using. So any countries is a comment from the R natural earth. We are merging two objects, our object with this object from R natural earth. And we are saying that we want the merge to be done using the codes, the country codes. We are just excluding Antarctica. We don't have data for it. And the next portion of the code is just the ggplot. The ggplot, sorry. And this is what we get when we run that code. So as you can see, it's a very nice picture with all the countries in the world, with the scale and changing the color. The color changes with this scale here. If you search online, you can see that you can use several other types of coloring of other scale field. And so it's a very nice picture as you may see it. Next, we are just changing the code, highlighting it in yellow. So we are collecting the data for the same variable for the same countries in 2008. And we also had to change here the object because we created a new object with the new time period. And this is the new plot. So you can see we easily done, easily configured, and easily reproducible. Finally, we are just changing again the year of the figure. We are using 1991, and we have also to change the name of the object here for the correct left join, for the correct source of data. And this creates this new plot. So as you can see, with as time goes by, 1991, 2008, 2019, we see that the yellow color and the green color tends to go away. So we can usually use this type of data to our research, to the projects that we are interested. And we can also create an GIF, an animation of these plots. So this can easily be done too. Other examples. So now we are changing the indicator. We are interested in the GDP per capita that we used at the beginning of this presentation. We create a new object. Here we have to change the name of the variable, and we have to change the source too. We change the object. We change here the variable that we are interested. We also changed the scale, because before we had a percentage for the self-employed, and now we are dealing with dollars, with US dollars. As doing so, we had also to extend the legend. So we extended it a little bit. Otherwise, it would be too short. So we had to extend it a little bit because it's using thousands of dollars. And we changed the title with the object name and the source with the object source. And oops, sorry, not this one. This one. Okay. So maybe you, okay. Oh, I jumped here. Sorry. Yeah. Here I am. Okay, good. So you can see the GDP per capita in constant, in fixed prices, fixed 2010 prices. And you see the legend here that it's extended. So it's a cool graph, nicely structured with good colors. And we can see that the inegalities around the world are quite big. Next, we are using a monthly variable now. Unemployment for the month February 2020. So we create a new indicator with the variable and the code provided by the World Bank, a new object. Now we see that we added 2020 M02, meaning that we are using the second month of 2020, February. We changed the name here. I excluded the source because it was a bit confusing, the source provided by the World Bank. So I inserted here manually the Global Economic Monitor from the World Bank. And the scale, we changed it again for %. And this gives us this new graph. As you may see, several countries are in gray, meaning that there is no data available for these countries. And for the other countries that data are available, we can see the colors. So it's interesting to notice that in South Africa, for example, the unemployment nowadays is very high. as it is in other Latin American countries and Spain, for example, Greece. So it's an interesting tool to analyze data globally. Next, we are using the life expectancy at birth for females in years. So we grabbed the code from the World Bank using the WDI search that we did at the beginning. We create a new object, and next we had to change the name and the source to match the life expectancy at birth for females. We changed the object here and the name and also the scale. Now we are using number format because it's years, so we have to use numbers. And here we have the object name and the object source. And this gives us this beautiful graph. So it's quite interesting to see that in Africa, the expectancy of birth of females is quite low. And in the other countries, it's relatively higher. So it's very interesting to analyze several countries at the same in the same picture, and you can easily do that by changing the indicator using the WDI package. Okay, now we are doing the Hans-Rosling's Gapminder graphs. Maybe when you type it for data in Google, you found the same graph because the guy is now working for Google. So this structure, this plot structure that we are using is the same that's provided by the Google data platform. We are analyzing three indicators: life expectancy, GDP per capita, and population, with the codes provided by the World Bank. We create a new object. We extract the name of we use the name of the countries. And then with this object, we are creating this new graph with logarithmic scale for GDP per capita here, as you may see here. And population, it will be in a number, but in millions. That's why they are putting this here. And as you may see, the size of each country, it will change according to the population. So here's the graph. So colors change too. So each region has its own color, which is quite interesting. I'm sure some of you have already seen this type of graph in Google. So it's the same thing, but if you can do whatever you want with by changing your code and using World Bank data. So the bubble here, it changes with the size of population, and you have in this axis the life expectancy at birth, and at the bottom you have GDP per capita in logarithmic scale. Now what we're going to see, we're going to filter this graph to analyze specific things that we are interested in. For example, myself, I was interested in knowing which countries have a life expectancy higher than 84 years and countries that have life expectancy lower than 55. To do so, we are going to use this package called GG Repel, and we are adding the geom label repel. So by doing so, we are creating this plot here. So you can easily see the labels added with the new code, with Japan, Hong Kong, and Macau at the top. Those are the countries with life expectancy higher than 84. And at the bottom left, you can see countries with life expectancy lower than 55. Next, we are going to subset, we are going to filter these once again, but now we are restricting population to 90 millions. And we are also changing a bit here to manipulate the labels so they are not overlaying each other. Oh, sorry. So here is the result for this graph. So it's, as you can see, it's very clean. It's very easy to handle and to reproduce by anyone else. I hope this presentation helped you to have an idea what you can do with WDI package. And I'm open to your questions, and feel free to contact me at my email address or on Twitter. So I'm free to exchange with you if you're interested. Thank you very much. I'm going to check the chat now because I wasn't seeing it. So let me just see if we have some questions here.
Can you maybe briefly go back to how you search the different series that are available in the package?
Yeah, sure. Just a moment. Let me share my screen once again. Okay. So I think you mean this section here, right?
Right.
Okay. So here it just is just an example of searching searching for GDP. When you do that, we know that the World Bank, there are several variables with the keyword GDP. There are hundreds. Actually, we can see here at the GIFI, we have 539 variables with GDP. So if you want to look at these variables, at these 500 variables, we save an object called GDP search. And by clicking it on this object, we can easily search for something as presented here in the GIFI. So you can type, for example, let's see what's services. If you type services, it will give you all the variables that have GDP and services on its name. And you can do it for other names too. You can put, for example, infrastructure. You can put innovation, prices, and so on.
Very good. Thanks.
All right. You're welcome. Is there any other question? Feel free to unmute yourself and to ask. I'm going to check the chat here. So I'm sorry about my micro. I don't know if it's all right now, but about the code, Mathieu, he provided the link. Okay, cool. Next, what we have here, what package do you use to create a GIFI? Actually, I was not using a package. I was using a software. It's called a screen to GIF. So it's a portable software. You don't even need to install it in your computer. And I think that's okay. But you can do it on directly on R. Actually, we can do lots of stuff directly from R. So it's a very vast universe. Second, a question from Audrey. Okay, if there's a problem in your PDF, indicators, it's not working, the code. Okay, let me just open here and we are going to check this together. If you have other questions, please just put in the chat or unmute yourself. Just a second here. I'm going to share my screen too. What's the error message that you are receiving? Is it something specific or? Let me. I'm going to share my. Just a second. I'm going to share my R screen. Can you see it? It's fine? I guess so. So these files are available at the website, at the GitHub. So let's just do some, here you have the package that are needed. So if you run these, okay. And then we do the WDI search. And then we save this object. By clicking on it, you can open the object here. That's the GIF that I was showing. So infra, there's nothing, but you put, for example, local currency unit, you can see the filtering. So the part that is, okay, indicator, dot, and head. It's fine, indicators, dot, and head. It's working fine here. So I'm not sure if you loaded the package or not. Maybe you have to do a library WDI. And maybe it will work. So if you try this, I put it here at the. If you type this before that command, that may work it. It may work. Let me know if it's good, please. On the slide, okay, so let me, yeah, I will have to check it later. I cannot open your file right now, so you can drop me a message at my mail address. So I'd be very happy to answer it and to go through the. Okay, so any question? Okay, so I think it's all good. I hope you like it, and it was a real pleasure to do this presentation for you. And feel free to contact me if you have any question, any doubts about the package, about this presentation. The R community is so well developed that you can easily reach the authors of the package, for example. You can ask them questions. You can also use Google to look for the information that you're looking for. But feel free to reach me. Okay. So I hope you guys stay well. And if you have any questions, do not hesitate. I'm also another beginner. Don't worry. We are learning every day. So thank you very much, and see you in the next time. Thank you.